Have you ever caught yourself pondering, why isn't the sky green or perhaps a vibrant shade of purple? It's a fascinating question that has intrigued many of us. Now, there's a common misconception floating around that suggests the sky is blue because it's reflecting the ocean. But let's debunk this myth right away. You see, regardless of whether you're in the heart of a bustling city, atop a mountain peak, in the middle of an arid desert, or on a remote island, the color of the sky remains the same. It's not influenced by geographical location or proximity to large bodies of water. So it's quite clear that our sky isn't playing copycat with the ocean. But then what's the real reason behind its captivating blue? Well, let's unravel this mystery right away, with no time to waste. To comprehend the sky's color, we first need to delve into the nature of sunlight. Now picture a rainbow, a picturesque arc of colors, each band distinct and vivid. This is sunlight's self-portrait, a revelation of its true colorful identity. From the warm hues of red and orange to the calm tones of blue and violet, each color represents a different wavelength of light. But sunlight doesn't work alone to paint our sky blue. Here enters the atmosphere, this vast blanket of air enveloping our planet, acting as an active participant rather than just a passive spectator. The process responsible for this interaction is called scattering. As sunlight enters the atmosphere, it encounters countless tiny air molecules which scatter the light in various directions. You might now ask, scattering, but what does it have to do with our blue sky? Well, not all light is scattered equally. The short wavelength light, the blues and violets, are scattered more than the long wavelength reds and oranges. But why isn't our sky violet then if blue and violet light are scattered more? That's where the sensitivity of our eyes comes into play. This brings us to the world of Rayleigh scattering. It may sound like a term straight out of a science fiction novel, but it's actually a quite straightforward and everyday phenomenon. Imagine the sunlight as a group of enthusiastic travelers, each wearing coats of different colors, representing different wavelengths. As they journey into the Earth's atmosphere, they scatter or go off in different directions. But here's the twist. The travelers wearing the blue and violet coats scatter more and travel in all directions compared to their friends wearing red, orange and yellow coats. But if blue and violet light scatter more, why isn't our sky violet? Well, our eyes are more sensitive to the blue light and less sensitive to violet light. Also, the sunlight that reaches us does so more from the blue part of the spectrum rather than the violet. So when we look up, we see more of the scattered blue light. So there you have it. The sky isn't blue because it's reflecting the ocean or because it's feeling a bit down. No, it's blue because of countless tiny particles in our atmosphere scattering sunlight, with the blue light being scattered more and our eyes being more receptive to it. And that, my dear friends, is why we live under a blue, not violet sky. A simple phenomenon, yet a crucial one that adds a touch of color to our world, literally.